Hi. Just get the mic in order here. I apologize in advance. My slide presentation software seems to not really like this resolution, so we're probably going to be futzing with it all afternoon, but we'll get by. How many people here consider themselves, or I should say, how many people here use test-driven development in any way, shape, or form at any time in their lives? How many people use RSpec? How many people test regularly? What? How many? Say which part again? Oh. How many people test regularly? How many? Oh, I don't know. I could do this all day, frankly. But, okay. What we're going to talk about here is we're going to talk a little bit about two challenging problems in creating, in testing. And, the other one was how many people have actually downloaded and got the Rails app running? That is disappointingly low. If you haven't, okay, people who have it running, everyone else try and get it. Otherwise, when we do the hands-on stuff, and we'll be doing some of it will be interactive with you guys, like walking through situations with me, and we'll have a couple of one or two hands-on parts completely. If you do want to work with somebody that's got it up and running and you want to pair, that would be outstanding. It's really valuable sometimes in a situation like this. I understand that we don't know each other and that's awkward, but it's also sometimes really valuable to try and solve these problems while talking to somebody who is also struggling through them rather than trying to do them silently. Pro tip, it also helps me if I'm walking through the hall and I can hear two people talking to each other, I can get a sense of what might be the problem, what might be a sticking point in a way that I can't if you're just staring mutely into a screen. So that's my pitch for pairing in workshops. And now we're going to talk about two hard problems here. The first one is creating data for tests. In other words, creating data for tests that is, you want something that's easy to set up. You want something that's going to be fairly robust, that's going to prevent your test from failing for trivial reasons. And we're going to talk about some of the techniques for doing that. We're also going to talk about limiting tests to a particular part of the code. How many people were in Sandy's talk this morning? Almost everybody. Oh, that's good. She talked a lot actually, talking about unit tests in terms of having a test be focused on a particular part of the problem. One of the things that you also don't want is you don't want a test to fail because some other part of the code is a problem. You don't want a test to fail for a reason that's unrelated to the reason why the test is there in the first place. So we're going to talk about that. Now, it turns out that one of the things that makes creating test data hard is when you have a lot of data that's entangled. If in order to create a purchase, in order to simulate a purchase for unit test, I also need to create a user and a product and a line item and all kinds of other complicated object tree stuff. That works against easy setup in a test context. Yikes. Similarly, limiting your test to a particular part of the code is also challenging when your objects are entangled. Again, if in order to test my purchase code, I need to call all kinds of other methods that are owned by other classes, those are all potential breakpoints for tests. So the bright idea here is let's try and keep our objects from being entangled. And one of the ways that you do that in a TDD system is by driving the design with tests. So we're actually going to talk about that as well. So really we're going to talk about one hard problem, which is how you drive modular design with tests. Now, a couple things that I like to point out at this point in the proceedings. There's this weird quirk about teaching TDD. I've taught test-driven stuff for a few years now, and one of the things that is always a sticking point is that when you are telling somebody about TDD and you are explaining it step by step and you're taking 5 minutes to explain each line of code in a process where you're continually going back and forth between tests and code, it makes it feel really, really slow. In a way that I'm asking you to trust me is not true if you really do strict TDD in practice. It's much faster, but when you slow down to actually explicitly explain every test, every line, quickly we're 20 minutes in and we've written 3 lines of code, and people go, like, what's the point of this if it's going to take me 20 minutes to write 3 lines of code? It's not. It just takes me 20 minutes to talk about 3 lines of code. But they'll be the best 20 minutes of your life, trust me. Or the best 20 minutes of my life, one of the two. So also, this example is, it's an example. It's obviously missing things like security and views and design and all the stuff that would turn this from being an example into a web app. I know that. It's on purpose. We're just going to focus on stuff that's interesting from the point of view of testing. To a certain extent, we're over-specifying here a little bit. We're going to pick up on very, very subtle things in the tests to turn them into more modular pieces of code. Again, it's an example. Okay. Finally, you're here partially because you know this. Testing is considered, for better or for worse, test-driven development is considered in this community part of being a professional member of the community. So, hopefully you will come to something like this and learn how to do it better. Okay. So, we're working with a website, and let me get it running. If you have the app running, oh, I have it running. It'll look a little bit like this. Also not liking the resolution a whole lot. This is, of course, a travel agency catering to time travelers, because what else would it be? And if you're this is an example I use a lot. There's not a whole lot to this. I just want to point out that this application actually does run. If you have downloaded this, if you downloaded the application from GitHub and followed the instructions on the GitHub site and load it, you should be able to see something like this. Okay, so there's not much to this website. It's got some data. And the data is primarily, the site is made up of trips. A trip has a start and end date, which is the actual, the time travel date you're traveling to. It's got a couple of other data points that are less interesting for us at the moment. Also, in terms of the data, a trip has 1 or more hotels that are options for people to stay when they go on the trip. There are also multiple activities that a user can embark on when they take the trip. They can voluntarily choose to purchase them or not purchase them. And then we also have users. Okay. And what we want to do here is we're going to talk about users purchasing a trip. Okay. And just to be clear about what the requirement here is, a purchase overall is unifying a user, a trip, a hotel, a set of days the user is staying at, presumably, and 0 or more activities. And what we want to do is be able to calculate the price, the overall price of this trip. We want to be able to calculate, we want to be able to run this through a pretend purchase gateway. We need to check whether the hotel is even available. So we have a couple of processing things that we need to do. Okay, we're not going to worry about the view logic because, first of all, it's a pain to test in ways that are uninteresting to us for the purposes of this. It's a pain to test in a different way than some of the stuff we're going to talk about is a pain to test, and we're just not interested in that right now. Some other time. Okay. So where would I start? Like, given that requirement here, we're going to start dealing with users purchasing. Like, this is the interactive portion of our program. Where would you start? What would be the first thing that you might consider doing? I am perfectly capable of standing here mute until somebody raises their hand. So, I'm sorry.
Adding a trip to a cart?
Adding a trip to a cart, perhaps. Yeah, a cart's a cart. Let's assume for the moment that it's just a button and we're not worrying about carts. It's just going to go straight through.
Let's start with the user. The user
Okay.
is the most important part of this application.
So what would you actually test as part of starting with the user?
The user can create an account, log in.
Okay. Let's assume that's already there. Okay.
So they log in.
They're logged in. They're going to click. The functionality that we're talking about here is they see a trip, they click a button that says purchase, and we're going to assume that it magically, like we're going to assume that it goes through and it purchases something. Okay.
Let's test that you can find a trip.
Okay. So generically, there are three different, like, there are two different approaches here, and then like the non-approach. We can start from the top and start with an end-to-end test. This is sometimes called outside-in testing. We can start with a end-to-end test that essentially would cover the entire span of the feature, or at least cover more than one unit working together. And in something like this, it might be Cucumber, it might be Capybara. We're not really going to cover the end-to-end part here, but you might have something that looks like a user clicks a button, and then I check to see somewhere that the user's list of trips includes the new purchase. The other option is to start from the bottom and start building up individual units and work towards all of the different units you need to make this functionality work. And that's where we're going to work. That's the part that we're going to talk about right now. Another option is to just dive right in and not test and come back and catch up with the test later. And I mean, like, what's wrong with diving right in? Like, I think I know how this works. This isn't that hard. I mean, I'm sure you've probably done it. You've certainly heard it. I don't need to write tests for this. This isn't that hard. I can make it work. So what's the problem? Yeah, so that's one great thing about testing is it does help you sort of clarify and finalize your requirements. Also, it helps you drive the design, and it's similar to specifying your requirements. It also helps you think about the API and how these objects interact, because all of these objects in your system need to interact with the tests. So you can start thinking about how they interact with other objects in general through thinking about how they interact with tests. And of course, sometimes we think we know how to do something and we think it's going to be simple and we are just wrong. And it turns out to be, suddenly you're refreshing the browser over and over again thinking this would be much, much easier if I had just written a test. It also gets, I'm sure again that most of you have seen this, it also gets much, much harder to build tests into a system that has already started, that has already been built without tests. And we'll see a little bit, I think, as we go on why that turns out to be the case. Okay. So if we're working bottom up, then we kind of have to think about what the pieces of this functionality are. So we have, it needs to calculate the price. Assuming these are the requirements, it calculates the price given hotel, options, or whatever, a trip, hotel, activities. It's going to calculate tax. We don't know the rules for that yet, but I'll give them to you at some point. And if we get to it, it's going to validate whether the hotel is available and then validate the payment against a pretend gateway. Okay. So assuming we're going to start from the bottom and we're going to start by calculating price, what's a good place to start? What's a good first test? Or maybe more generically, where do you go? Sorry, I'm trying to get my speaker notes up here because the screen won't support it. What kinds of things do you think about in terms of starting a test? So here are some options. We can talk about testing an initialized state first. You almost always can start there. There's almost always an initialized state where, ironically, this problem doesn't have much of one, but there's almost always the user, I create a new user, the user has no purchases kind of test that you can write to build up. And then another good place to go is the basic happy path, the simplest thing that works, the simplest piece of data that makes it work. And then this is a great pair programming trick, but you also can do this by yourself. You start thinking about what makes this test break. What's the next level of data? Will it break if I pass in a different number? Will it break if I pass in a more complicated piece of data? Will it break if I pass in nil? And eventually you get to the point where you can't think of anything that makes it break, and anything that makes it break after that we call a bug. But anything that makes it break up until then is just part of the testing process. And then finally, there may be some special cases that you can think of aside from what makes it break. There may be some cases that you know that you need to handle, specific ways that you need to handle errors or things like that. Let's see how this works. Is that visible? It's almost visible. God. Okay. Put this in a text editor. So if you go into the actual travel piece, you go into the code, the purchase spec thing. We have some stuff commented out here. Looks like, is that big enough for people to read? Can you read that in the back? Yeah? Good. Okay. And let's create the most basic, easiest way of doing this. So this is about as simple a test as I can create here. There's very little data setting up. I'm creating a trip. I'm using RSpec's let mechanism to create a trip. Do people need me to go through the RSpec syntax here? I'm happy to. Huh? Yes? No? Anybody? Yes? Okay. So RSpec works in a couple of different structures. We have the structure here, a describe structure, which takes as an argument either a string or a constant and then a block. And that's effectively you're defining a suite of tests that are all related. They can be nested as they are in this case. So the outer block is referencing the class that we're talking about. The inner block is referencing just that these tests are all related to pricing. And then inside the describe block, each RSpec uses it to delineate a specific test. It takes a string describing the test and a block. The block is the body of the test. RSpec also has this mechanism where you can specify a symbol and a block, and this symbol on first use is lazily initialized. Sorry, this is actually. Let me do it this way. Let me actually take away the initialization for the moment. Inside the body of the test, we're creating a trip using active record. We're giving it a price. We're creating a purchase that includes that trip. And we are specifying that now that we calculate the price of that purchase, it'll be just the price of the trip. We're not adding any hotel information. We're not adding any activity information. So this is about as simple as our code can get. And we can make that pass by creating. This font thing is going to be the death of me. We can make this pass by creating a purchase class, and it's a little bit more elaborate in the code as you finally have it. But all we're doing here is we are creating the purchase. It's going to have one accessor. We haven't specified it as an active record model yet. but we're initializing it with a trip, and we're classifying the pretext total as being just the price of that trip. Now, there's an argument that this actually isn't the easiest, the simplest way to have made this test pass. What would have been the simplest way to make this test pass? Return true. Yes, you have the right idea, but not actually. You have the right idea, but the wrong constant. Yeah, just return the 200. Just return the 200, and that works. It passes the test. What would be the advantage or disadvantage of having this purchase? Let me go back into Chrome. Of having this purchase just return 200 instead of the price. Is there an advantage to doing it that way? Is there a disadvantage to doing it that way? Let me put it this way. Who has done something like this in a test to make it pass? Okay. A couple people. Why would you do that? This is the least amount of work, right? It's the simplest thing that could possibly work. And then actually it drives really nicely into the next step of what do I test, which is how do I make this break? Because then you, ideally, you would create a test that has you could create a new test that has another trip with a different price. And at that point, the simplest thing to make them both work is to just do the math. So what's the advantage of doing something like that? When is it advantageous?
It drives the quality of your test.
It drives the quality of your test. Could you elaborate on that for a second?
So you have to have more comprehensive tests. You have to test more scenarios.
Okay, so the argument here is that by requiring your code to be that incremental, you're sort of forcing yourself to think incrementally and allow the test to drive the design.
Sometimes very basic things fail in surprising ways. Maybe you're on the wrong method.
Yeah. That's a really good point. I think especially in development, you always want to have a failure. And I think if you're doing test-driven development and you find yourself writing a lot of tests that pass without you having to do it, that's a good sign that you're not really doing test-driven development. You're just writing tests and code next to each other. You're not really driving. If the tests aren't pushing the boundaries of what the code does, then you're not driving the design with the tests. And if you don't start with a failure, you don't necessarily know that the test is doing what you think it's doing. One of the worst things that you can have in a TDD environment is a test that passes even though its underlying code still is bad. That's rough. There is a downside. So I find this approach, Gary Bernhard in one of the Destroy All Software screencasts calls this approach sliming the test. And I like that term a lot, so I'm trying to popularize it. So I find that this approach in building something up is very effective in the case where I know very distinctly what the right answer is, but I don't know what the algorithm to get to it looks like. And that, to me, is the case where I really try to go in very small baby steps. As opposed to some cases where I do think I have a good idea or where it's not as algorithmically complex. Anyway, the test passes, I hope. Probably should check. It's something that's going to screw up because I have this in a weird state with quotes and things like that. See? Purchase spec. No. Okay. Test passes. Yay, we're done. I find that one of the hardest things to get people in the mindset of testing is the idea that it's actually okay to have this be there for a while. That sometimes people get really either half of this, because trip.price is obviously oversimplified for this problem as well, But I also find that people get really hung up on the idea that if the test passes, it has to be right. And I think that it's much more, if you get comfortable with the idea that incomplete correctness, which is a weird kind of phrase, but incomplete correctness is still okay, as long as you know that you're not done, then I think you're going to find, then the test process, I think, starts to make a lot more sense. And again, this is a great thing, this is a great tie-in with pair programming. If you pair programming with somebody and one person is writing the test and one person is writing the code, and then the tester is trying to break the code and the coder is trying to write the code in the stupidest way possible, so as to get at so as to ignore the intent of the test, you actually wind up with really good stuff. Okay, so we have our test pass, but in the fullness of time, trip accumulates a bunch of other stuff. In particular, it accumulates all of these validates presence of. What does those do? Each of these, we're validating the presence of. What? Yeah, so it forces us to have this value in every single trip. Specifically for our purposes, what do each and every one of these do as they individually get added? Huh? I heard it, what? Break the test. So this is the problem with creating test data, right? We don't want this test to break. We don't want this test to break every time trip gets a validation because we're not testing trip's validations here. And yes? Create saves it to the database, so it will fail. Huh? Trip's create, yeah. But you're like a slide and a half ahead of him because that's one of the things I'm going to say. It's one of the ways to get around it. We're not testing trip's creation at all. And we're certainly not testing its validations. And one of the things that becomes really demoralizing in managing a large test suite is the idea that every time I look at the code cross-eyed, I break 5 tests on the other side of the world. And that is a really quick way. There was I don't know if any of you are on the Ruby Rogues Parlay mailing list. There's a discussion of testing on there. Is anybody there on there? There was a discussion of testing just a couple of weeks ago. And the person who was trying to make the claim that tests were overrated said that they had an algorithm with a lot of different weights that they were testing, but it was set up so that every time they changed the weights, the tests broke. And so eventually, they stopped updating the tests, and therefore the tests weren't valuable. And I completely see that. The part that I don't, the part where that becomes a problem, and the part that I'm hoping that we'll be talking about here, is the idea that the test broke every time that they changed the weight. Because that's really the idea here is that you don't want tests to fail for purposes that are unrelated to the test's existence. So, one of the ways we wind up with it, one of the things that happens with this is that our test eventually becomes this. Okay. And there's a lot that's bad here. What are some long-term problems of this? Right, we haven't solved the underlying problem. This test will still break every time we add new validations. Right, so every time, it's even worse than that because every trip test has these 5 lines of stupid boilerplate. And close your eyes, look back up at here, and then tell me what the important value is there. What is the purpose of this test? Why am I creating this object? And then there's just the sheer amount of typing that it takes. This is bad. Okay, you take nothing else from the first half hour of this. This is bad, don't do this. But what are the alternatives? So one of the alternatives is don't save it to the database, because that's where the validation is happening. Another one is fixtures. People have used fixtures, Ruby's default, Rails default fixtures. Factories, people using factories, more people using factories. Stubs in this context. Okay. I'm going to go through this a little bit one at a time. Not saving to the database is actually not a bad idea. It's not always the right idea, but it's often a really good idea. As Rails programmers, we've accepted this idea that it's okay to have something that we call a unit test that touches the database, which is this massive third-party dependency. And we have kind of, as a group, sort of agreed not to talk about that. Like, we just don't, Rails makes it so easy to touch the database in a unit test, which is great. Definitely beats the alternative. But it allows us to kind of blur the line between a unit test and not a unit test, since we save things to the database. Okay. One problem with that is that you can get away with not doing all the validations, but then you are wandering through the system with an invalid object, and there's a pretty good chance that that may trigger some other failure somewhere else down the line, depending on how your system's set up. And then finally, in this case, Rails associations have this stubborn habit of working on IDs. You only get IDs when you save things, and therefore, if you're testing stuff that depends on a Rails association, you often need to save something to the database in order to make the association behave properly. Sometimes the rebuttal to that is, why are you testing a Rails association in that way? And sometimes the rebuttal to that is, you should save it to the database anyway. Saving to the database, though, is really slow relative to this. And how many people actually are dealing with the problem that you have a test suite, but it's super slow, and that's getting in the way of doing stuff? So yeah, this is one of the mechanisms for speeding up a test space, is just don't save stuff to the database when you don't need to. Rails actively fights against that, which is a whole nother story about objects in Rails, but I only have an hour and a half of your time. So fixtures. So I'm sorry, who's never used fixtures? Who doesn't know what I'm talking about? So we have a sense of here of people who kind of know what this is but have chosen not to use them. Is that correct? Okay. I'm going to try to rehabilitate this in a very, very limited kind of a way. So the way that fixtures work in Rails, in case you don't know, is you have a YAML file associated with the model. Each element of the YAML file has a label, and then it's got a bunch of key value pairs. If it happens to have an association, you can refer to the other part of the association by its label, which is actually really convenient. This is actually also parsed in Rails via ERB, which means that you can dynamically do things like update, start, and end date throughout. And then you use it. This may be a little bit hard to read, but the important part is here. It gives you a sort of a global method where you refer to it by the model name, the plural of the model name, and then the label. Okay, so who wants to give me the pro-fixture argument? Anybody want to be bold enough to say why fixtures? I mean, fixtures, for all that everybody kind of curled their lip when I said fixtures, half of you, right? Who curled your, right? Fixtures were amazing when Rails first came out and had them. It was a huge step forward. And the positive case here, there's, to me, the strong positive case is Rails fixtures are super fast. Does anybody know why Rails fixtures are really fast, the implementation of them? Yeah. Rails throws all the fixtures into the database that's transactional. Rails throws all the fixtures in the database, then runs each test in a database transaction and rolls it back at the end so you get back to the state of all the fixtures. So you have, in a case where you need to test against a huge object tree, you can have a huge object tree and not suffer the cost of having to save 25 objects into the database on every test. They're relatively easy to set up associations, again, because it's a subset of it being fast, and they're very concise in the code. I'm sure, though, that all of you can tell me the downside of fixtures, since many of you seem to stop using them. Why did you stop using them? They're very brittle. Why are they brittle? What? What? Yeah. So they're brittle in part because if you add a new field, you need to update all your fixtures. They're brittle in part because they're global and opaque. And so if you go back to this test here, we've actually lost an important piece of information in this test, which is this 200 now comes out of nowhere. So this is basically a magic literal. And that's an important piece of information that we've lost. We now have to go to the fixture file to find that. And they're global. So where I actually have come to use fixtures is in the case where I don't really care that they're global, but I do, and I don't even really care that they're opaque, but I do care that they're fast. I've started to use fixtures in setup for cucumber tests or acceptance tests because that gives me more realistic data set. And in a case where the global part is less important to me, because there are fewer tests and fewer cucumber tests, and therefore there's fewer tripping. But I certainly have been in the case where we had a big fixture suite and we had search that was being tested against it, every time somebody updated a fixture, 25 tests would break. That sucks. By the way, it's coming up on 2:45 if you were going to be here for the first half of this, and we're going to leave to catch a second half, 2:50, I think, to 3:30. Is that the... I'm just saying. I'll close my eyes. People who aren't here in 30 seconds. No harm, no foul. Okay, factories. Factories, who's using factories? Okay. So this is Factory Girl. Syntax for this, and it looks very similar to fixtures, at least in the base part of it. You set up the class name effectively, and these are all, they're technically method calls. They're attributes and values. They can also be dynamic. You have all sorts of cool things where you can set up associations. You can set up sequences. You have a fair amount of flexibility there. And what's especially nice is that when you create a fixture, you can override individual pieces of data. And this solves the problem of that 200 being magic, and it also solves the problem of the test being brittle against new validations or new requirements. Because what happens here is the factory girl, the default, should pass all the validations. So if we add a new validation, all we need to do is update the factory in one place. But we still can specify the attribute here as a marker that this is the important part of the test that we're working against. Okay. So fixtures are pretty easy to build. They allow you to be flexible. You can choose to put them in the database or not put them in the database. You can also create, in Factory Girl, you can have the factory create a set of key value pairs to pass to a controller, for example. And you can have them create a stub. They're really handy. What's the downside of factories? Slow, especially when? Well, writing to the database is one thing, but factories are very, very slow.
Oh, well, you're using associations.
Yeah, when you're using associations. One of the great things about Factory Girl is it allows you to specify as part of the factory an association. The downside of that is that every time you create the factory, it creates the associated object. If you've got a purchase that has a trip, that has a user, that has a hotel, that has 3 activities, suddenly in order to create one object, you've built up a 10-object tree. Not to tell tales out of school, but this is largely how the Groupon codebase wound up with a 45-minute unit test suite. And that was already having been pushed off of people's machines onto servers. It's not that anymore, and I don't work there anymore, so I have no idea what it is anymore. At one point, that was where they got, and that was exactly where they got in trouble, was they had a bunch of factories that created associated objects such that they were building up complicated trees all the time. Okay. So the other way to do this to create the data is to create a stub. So how familiar are people here with stubs? What am I doing here?
Just creating a mock object.
Yeah, I'm creating a mock object here, and I'm preserving, so this is creating an object that basically has no purpose in life other than to respond to the message price and return 200. It does nothing else. And I'm throwing that in here, and I am, the rest of the test stays the same. Still works. And what's great about this, so there's some stuff about this that's great and some stuff about this that doesn't work. So how many people, I should say, who uses this kind of test? Who would use this kind of test like casually in terms of something they would do regularly? Who finds this off-putting and strange? Who has fallen asleep or is what, or is, ha ha ha, a little knowing laughter. So there's some things about this that are really valuable and some things about this that are brittle. And in part, and Sandy Metz was making very similar points about this earlier in her session. Whether this is a good thing or a bad thing depends on how you're using it. We're making a very strong claim in this line, which is that
Price is the only thing.
yeah, I don't care. Price is the only thing I care about. I don't even care that it's actually a trip. It could be I don't know, something. It could be a cheeseburger, huh? Yeah, it could be a widget. It could be anything. And this test is actually becomes very robust against that kind of change. Okay. So not only are we specifying the test here, but we're actually going a long way towards specifying the design and the interface here. We're saying that when I create a purchase, the purchase cares about the price. That's not an incidental feature, and that's the thing that it cares about. So not only are we getting towards how making this test pass just as a matter of functionality, we're actually starting to drive out our design because we're making a strong claim about the design. We're not really making a testable claim about the design. If we wanted to make this a mock object, then we would, in addition, we would be saying not only is the price important, but if it's not there, fail the test. So that's the nomenclature. Stub replaces a method definition with a canned value. A mock is like a stub, but it asserts that the method is actually called. Spies, which are finally going to be added to RSpec in 2.14 sometime in the next several weeks, allows you to actually split this into two pieces, so I can specify the stub in one place, and then later on I could specify that it should have been called in two different pieces, which is a little bit easier to manage. Okay. So just a quick overview of these things here. We have the option of not saving to the database, which is fast but incomplete and doesn't really deal with Rails associations. We can use fixtures, which are fast but brittle. We can use factories that are slower but more readable and more focused. And we can use stubs, which are also fast and brittle. I think what you can easily get from this chart is there's no one perfect way to do this. But that actually using the right mechanism here can really help the tests both run fast and be fast to create. Ultimately, it's not easy to write the tests or run the tests, you're just not going to do it. Okay. So let me move on to an example here that might be a little bit more in terms of driving the test. Let me put this a different way. What is a good example here? What might be the next? Let me back this up a little bit. What's the next test I could write here? What would be, how can I make this test break? Yeah, actually, changing the price won't actually make it break, but if, because I don't think I have it specified as the, yeah, well, this is bad because the code is actually a little bit ahead of the tests because they're commented out. But really, the next test, I can make this break by adding more data. So if I add the concept of a hotel here, this test, notionally, because the code's obviously a little bit ahead of the tests because this is an example, this would be the next test, and this test would break. And so do we like this test? Is there anything about either the test or the API that it's implying about the way purchases work that we like or don't like? I mean, I think I'll tell you, there's something I don't like about this, but it's really super subtle for the purposes of the example. And I'm actually kind of wondering if anybody else sees it.
What is the 3?
Yeah, so the 3 is kind of magic here, yes.
Why are you separating out trips and hotels? They all just are things with prices.
Yeah, that's one thing. That is not quite where I'm taking it at this point, but definitely someplace to take it at some point in the future. You have all of these different things that have prices. Why am I treating them as 2 separate things? That makes a lot of sense to me. I was looking more at so the 3 is the length of stay here. So there's a couple of weird things about this. One is that this 350 now seems a little bit magical because it's actually 50 times 3 plus 200, of course. And also, it occurs to me as I look at this that, and this is, I'm slightly jumping the gun here because I noticed it, and it may not be at the point where it's worth driving this out, but these are 2 pieces of data that are going to get passed around together a lot as I'm calculating availability, as I'm calculating prices. We're often going to work together on 2 pieces of data that they're going to get passed in tandem. What does it mean when you have 2 pieces of data that get passed in tandem a lot? Does the code smell? What? Yeah, it's a really strong sign that you have an abstraction that's not there yet. Now, again, I'm sort of pushing the gun here because this isn't getting passed all over the place. I'm already just sort of suspect that it is. So actually, I can think of that as its own object that I can call a hotel stay. How should I create the hotel for this test? What might be a good option?
You have a hotel model?
I do have a hotel model, as it happens, because there actually is a hotel model. But I can stub it with 50, and I think that passes. Yeah. So why stub it? As opposed to we only care about the price? Yeah, I think those are both good. Those are both good instincts. Like we're not the fact that we actually have a hotel here. The fact that we actually have a physical hotel here is interesting and may be valuable at some point. But if we're calculating the price, then the only thing we care about is the price. And again, we're trying to focus this on we're trying to limit this to the actual method under test and the actual object under test. So stubbing in this case actually really does that in a way that Factory Girl doesn't. Now, the other thing about stubbing, which is good and bad, and which is part of what gives it the reputation of being fragile, is stubs are super, super sensitive to the design, the quality of the design, or interaction of the design. All testing is to some extent, and mock objects testing is really sensitive to it. If you're doing stubs, and this is where they got kind of a bad reputation, because if you come into a project in the middle and you start trying to stub out all of the messages that are going out from a particular method under test, you're going to wind up with a lot of them, and you're not going to feel confident in it. And that's often a sign, and people often say that that's a problem with mock object testing, which may or may not be true, but it often also is a problem with the underlying code. And I think that one of the things about the driven part of test-driven design is that you at least entertain the possibility that if it's getting hard to write the test, that indicates a weakness in the underlying code rather than that testing sucks. So we write the hotel stay test, and the hotel stay passes fairly easily here, hotel price plus length of stay, and then we come back to the purchase. And we have the same issue. How do we create these objects again? Well, the purchase we need to create. Sorry. Also note that with the only having 2 arguments here, the code's a little bit more self-documenting, because the attribute names work a little bit more to describe the intent of the code. And again, we're at the point where we don't care about the internals of a hotel stay anymore. We don't care how it calculates a price. You know, it can calculate it based on, who knows, season, you know, what kind of room it is. We don't care anymore. We just care about the final price, and that's all that we care about to get to the 350. And note that in this test, it's much easier to see where the 350 comes from. How many people are actually able to follow along and run this, whether or not you're doing it? Like if I were to say 1, 2, 3. Okay, we may not do the full hands-on activity in that case. Yeah, let me break here. That's exactly what. Does anybody have any questions, or is this making sense? Have any value? Yeah, you're. I could easily. I didn't originally because it was being covered by the let block up here, but it could easily, just as easily, be a stub. Yeah. And I think you're sort of. You have this tension here of, is it more readable for it to be a stub? Like, you know, is the claim that I'm making about the API more important than the claim that it's a particular object? You know, I don't know that there's necessarily a 100% answer to this, although this test, you know, we now have a very fast test. Any questions about this so far? Is this valuable, useful, horrible? I don't know. Anything? Yeah.
I'm following along and I'm really liking this.
Okay. I'm good so far. I'm with this so far, yeah. Yeah.
I encounter the other more often where people will, you know, do the database save and all that kind of stuff.
Right.
So they're actually doing integration testing and functional testing and things like that. Could you speak more to the value of doing it this way versus the other way, or maybe?
Sure. I guess one thing that made me think is, what didn't I do what haven't I done yet? Like I don't have a database migration. Purchase is not an active record object, in part because I suspect that purchase will never be an active record object, because I suspect that I'm going to wind up breaking this into a workflow object and a data object, but that's beside the point. What are the values of doing it this way? Well, one value is speed. Okay? This test is going to be very, very fast. It's going to be much faster than, let's see, we have like 3 or 4 potential active record objects. That's going to be, even at that point, it's going to be measurably faster in the sense that the clock speed, you'll notice it in the clock speed. And once you have like 10, 20, 100, 200 of these, it's going to be noticeably faster. I believe that really, to do actual D is for test-driven development, your tests have to run really fast. Like if you can break focus between running tests and having the tests complete running, it becomes much harder to do TDD. And break focus happens at like the second or 2 barrier. Once you get into 5 minutes, 10 minutes, 45 minutes, then you have a lot of bad options. You have bad option 1, which is, I have to run the test, and it's 45 minutes, and I'm going to go play Tetris or something. That was a dated reference. That was horrible. I'm going to go play Angry Birds. No, wait. I can work on this. Or you don't run the entire test suite, which has its own problems. Because maybe the tests for purchase run perfectly fine, but if I go to run the whole suite, I have other issues. It's not the worst thing to just run the test 1 file at a time if you're writing the tests correctly. But it does add an extra step because eventually you have to run the whole suite. And eventually you have to take that speed hit. And the speed hit often means that there's a problem in the design. So that's one problem. The other problem is the fragility problem. Like, again, it's really demoralizing when you make a change and tests break, and suddenly like 25 tests break. Like, ideally, and this is like code coverage, like a goal that you will never quite meet, but it is worth thinking about. A single bug or single logical problem in your code should cause 1 test to fail. And what's great about that is it's easy to diagnose. It failed. 1 test failed. Ideally, that test says, this should do blah, 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 and you can tell right where you need to fix it, right? If 45 tests fail because of the same underlying reason, then you have to dig through all of those to try to figure out which of those is the important test failure, right? And that is, that's horrible.
Can I just respond to that? Because I fully agree with this as an
Okay.
approach to doing incremental development,
Right.
test-driven development, when you've got something which is very, focusing on or just focusing on the purchase model.
Okay.
Or class or whatever it is, that's great. The pushback that I get is that, we have to do integration testing anyway.
So why not make our integration? So why not make our integration testing? So why not make our integration testing bad? I guess no.
It's not that it's bad. It's that
Okay. Yes.
when you finish unit testing
I-
your purchase
Right.
and your hotel stay and your hotel
Yes.
and your docking
You still need to do right, but you don't need to do like doing the purchase and doing all that stuff is going to be 25, 30 unit tests. I don't need 25 or 30 acceptance tests to make that run. I probably need 2 or 3 because I often don't test error conditions in acceptance tests because it's slow. So to me, that's the pushback. Like, yes, we need to do an acceptance test, but we don't need to do 40 acceptance tests because that's going to take forever, and then you're just not going to write them. The fact is that if it's slow to run the tests and slow to write the tests, then people stop writing them. And the problem with that is the absolute worst thing that you can have is a half-assed test suite. Okay, it's not the worst thing. You could have like Ebola or something. But, yeah, what? Yeah, you could have no test suite. I would almost rather have no test suite than a half-assed. The problem with the half-assed test suite, and this is where people go, my tests are not adding value. I don't understand why people like this testing thing. Because, and it's sort of this horrible, vicious circle. Like, if you half-ass your test suite because you're not comfortable testing, then you get in a situation where you are putting all of the effort into these tests, which first of all are probably brittle because you're not committing to it. And second of all, because you're not committing to it, you don't get coverage, so you don't get the benefit of having the long-term benefit of having a test suite, which is that you can make changes and feel confident. If you can't feel confident in changes, but you're still putting a lot of effort into the test suite, then even I, like professional tester, talking head moron, would say that that's probably not the best use of your time. And that's when people, to me, often when I see people say, like, my tests don't have value, they're right. Like, the tests don't have value the way that they're doing them. The other thing is that tests have two purposes, and there was a little bit of a tension between them. And we kind of got to this when we were talking about sliming tests a little bit. And there's the word again, I love it, the word. A test exists, first of all, to drive the design when you're creating the code initially. Once that code is done, the test stays basically until the heat death of the universe, right? And in the case where we were talking about, well, do we just make the price 200 and then we create another test with price 300 because we want to break that test, that's perfectly valid, rational thing to do in the test-driven part of the program. But once the functionality is done, it's worth it to go back and make sure that you need all those tests. Okay? And for a lot of the same reasons that we were talking about. Extra tests slow things down. They make things hard to diagnose. I fully realize that telling people that, like, yay, go delete tests is a little bit like handing people scissors, pointy end first, but sometimes, like, that's the way to go. A lot of these startups, a lot of the tests that you write when you're just trying to get started that are testing initialization status, that are testing, some other logical combination, you don't need them in the long term. They're just scaffolding, and you can take them away. Any other questions or comments as I try to figure out where I am in my presentation? Yes, I'm sorry. You're being very polite, and I'm not looking at you. I'm sorry. How? So how incremental do you need to be? Is that your question? So how many different, like, price points do I need to test hotels at? The guideline is, like, simple but tricky. At some point, like, the code on the code side should be the simplest thing that makes all the tests pass. Okay? And at some point, you get to the point where the simplest thing to do is the right thing. Like, if I were to say, write a test where price is 200 and I just return 200, okay, fine, that's simple. If I have another test that is 300 and then I do something like, I could potentially do something like, well, if the price is 200, return 200. If the price is 300, return 300. Otherwise, return, But at that point, it's pretty much easier to just go to the general case. Does that make sense? Like, the code you will reach a point where the simplifying piece of the code is generic enough that you can't break it anymore with some other dumb case. And that's where you get to. The question, like, of when to take small steps like that, again, to me, a little bit depends on what you're trying to do. And again, like, the more algorithmic, the more complicated the algorithm is, for me, the smaller the steps I take. One of the reasons why scoring bowling is a really good test-driven, like, practice kata is because it is almost the simplest possible case where it's really easy to calculate the answer. Like you can look at a string of scores and calculate the answer in your head, but actually the algorithm, the algorithm is not hard exactly, but it's surprising if you build it up test-driven development. And if you have not ever done that, it's worth actually trying it. To try to do that is a really strict test-driven development, and I almost guarantee that you will wind up with an implementation that is simpler than you think it needs to be. Okay. I'm going to skip over the hand piece. And I want to talk a little bit about, since so many people don't really have this set up, I recommend, I'll put the slides will go up on the conference page, on the Conf tutorials page sometime today. And I really do recommend that you go in and try the hands-on exercise that I have here, which has kind of a goofy, made-up tax requirements, because of course time travel would be taxed. Yeah, sure. Yeah, I got a whole backstory behind this. Really, you have no idea. And to look at that and really try and do this in a test-driven way and try to do it with the understanding that the weights and those numbers might potentially be volatile. But actually what I want to talk about here a little bit is, and I think given the time that we have, we'll maybe keep this at a talky level, which I apologize for. This hasn't been very workshop-y, and but I want to talk about a pattern for working with external services, such as payment gateways, or the JavaScript DOM, potentially, or a database. Once you start thinking about it in terms of third-party services, you'll see them everywhere. And the generic plan for me for test-driven development against a third-party service, so one of the issues here is, like, you don't want to hit the third-party service in your test. Like, you don't want to hit PayPal in your unit test. You don't want to hit the Twitter API in your unit test because, for one thing, you don't want to hit PayPal because you don't want to accidentally charge something. You don't want to hit Twitter because intermittently it's going to fail, and you can't diagnose that. And actually, at the same time, you also don't really directly want to call the API from your code necessarily. And so what I would advocate here is a structure where you write your own wrapper around this third-party server. And I even do this in cases where there already is a Ruby library. I often will write my own wrapper around it. And there are two reasons for that. One of which is that usually the third-party API is not really talking about the same concepts in the same terms that my application is. So I might be using a payment gateway, but I have a subscription model that doesn't really match their subscription model. I want the rest of my application to talk about my subscription model, not theirs. So I write a wrapper around it. In this contrived case, I have a case where I have a hotel availability API that only takes into account one day at a time. Whereas for my purposes, I want to talk about entire trips. So that's something that's my own application's language that I want the rest of my application to speak. So the rest of the code in your application then tests against your wrapper. You stub your wrapper. And then the rest of your code, for one thing, doesn't have to hit the external API, and for another, the tests are, again, in terms of your own application's domain model. And then when you want to test the wrapper, you have a couple of different options. You can integration test the wrapper by calling the API directly on a limited basis. You can also stub the API just for these tests, or you can use a tool. I don't know how many of you used a tool called VCR or WebMock. VCR is really cool. It essentially, you declare a third-party web API test with VCR. The first time it actually makes the remote call, stores the information, and then future times it uses that stored information. But one of the things that's cool about VCR is that every week or so it will go back and make that call once again. So if the API changes, eventually it will propagate into your tests, which is pretty cool. Okay. Yeah. You could consider Active Record a third-party API.
So should you not stub it? Or should you wrap Active Record?
Okay. Well, now I know what we're going to be talking about for the 10 minutes we have remaining in our session. So you could consider Active Record a third-party API. Should you? Well, if DHH were standing here, he would say no, that that's a ridiculous and absurd concept, and we don't need to build these kind of structures up. And that is one viewpoint. The problem with doing it, okay, I think in general it is a good instinct. I actually really do. I like the idea of keeping my active record objects having relatively minimal functionality. And wrapping them, in some cases wrapping them in stuff that's sort of orthogonal to the data model. The problem is that Rails kind of fights you. And that's a very similar to DHH would be up here telling you that that's a ridiculous idea. Like, it is baked into the Rails framework that that's a ridiculous idea. In that there's no, like, if you start talking about objects that are models but aren't active record models, like, where do you put them? Rails doesn't really have a place for them. They don't auto-load. You have all of these things where some of the nice features that you expect the framework to give you suddenly aren't there. That said, I think it's a really interesting way to build a system, and I actually have a whole nother, if you want, I can send you a whole nother workshop on that. It's a good practice session if you have like a toy Rails project, is to try to see how far you can take it and not put any logic in active record at all. And that gets kind of, you start building these little small surface objects and workflow objects and DCI context objects and stuff like that. And the conclusion, if you're me, the conclusion that you will come to, because the conclusion I came to, was that it is a good idea in general, but you can take it too far. And that's not because the database isn't a third-party dependency, it kind of is, but it's because it's a third-party dependency that's really entangled in Rails in such a way that it's sometimes not worth the trouble to tease them apart. You can ask a similar question on the client side with like jQuery or the DOM. jQuery is a third-party dependency. The DOM certainly is a third-party dependency. And you can do the same thing. Like, you can write wrappers around your DOM, and it's actually, you actually can get to some pretty nice places doing that. You write a little wrapper that represents a page. You call a semantic method, give me my form, and that calls the jQuery. And if you're starting to do Jasmine testing, if you're doing JavaScript testing, it actually works pretty well, and you only have to deal with the fact that nobody else who writes JavaScript will have any idea what the hell you're doing. But other than that, it works great.
The problem I've run into with Rails or active record testing and stubbing is especially with chaining associations or order limit and blah blah blah. So
Right.
if you want to stub it, now you just stub this record that returns this association that returns this association.
Right, and that's part of what I'm talking about that stuff being baked in, like, the finding stuff is baked really tightly into the database and all of that kind of stub stuff. What I actually tend to do in practice is really simple stubs, or really simple scopes, really simple scopes and methods, I often don't test on the grounds that they are they're really just very small extensions of the active record framework, and I don't test them unless I start seeing problems there. What I also tend to do is the kind of thing where you write class methods in Rails active record to do like complicated finders or complicated scopes. So you have this sort of thing here where these all used to be horrible blocks of code in controllers, and then people move them to be horrible blocks as class methods in active record objects, and I move them one more time to make them horrible blocks in their own classes, which are usually called workflow class or a service object or sometimes a factory, like in the classic design pattern sense of a factory. And when you do that, actually it opens up some refactoring opportunities in that object, and it kind of breaks that up a little bit. Am I anywhere near answering your question? I've just gone off and started talking again. So that's what I actually tend to do. I do sometimes pull things that are like, I have a start date and an end date in a class. I'm going to deal with those as a range all the time. I will sometimes create a range object, date range object, and have an accessor in the active record model, and then put tests in that range object. Related, I had another related thing on the tip of my tongue, and I don't remember what. Oh, sometimes I will actually also, I've done this once or twice where I will Backbone has this concept of collections separate from active record objects, and I've done that a couple times too, where I've created wrapped Rails associations in collection classes because multiple objects had the same association and they were using the same logic against it. So, and then you can test that object separately from the individual pieces of it. We're actually coming close in on time. So I actually, I knew, by the way, that we were not going to get through all these slides, so don't take anything into the idea that we ran through it. A couple things to walk away from this. Encapsulation in general in the object-oriented sense reduces cognitive load, by which I mean to say it reduces the number of things you need to care about at any one time in order to reason about your program. This is a good thing. Anybody who was at my talk this morning, I talked about a couple of different ways to go at this. Encapsulation is the OO way of reducing a cognitive load. You draw a circle around something, you can deal with that, and you don't have to deal with the rest of the universe. Okay? Tests can drive design. If Corey Haynes runs these code retreat things, which I recommend if you ever have a chance to have one in your neighborhood. Corey Haynes doesn't run all of them, but he runs some of them. And they do a technique similar to the ping pong technique that I described earlier, where one person writes the code and one person writes the test. The constraint, though, is that the two people can't talk. That the only way that the tester can communicate their intent to the coder is in the test. Think about that next time you try to write tests. It really will change the way that you think about the way tests drive design. Like, what if the tests were your communication portal to talk to the other half of this? And this one I said, if the test seems hard to set up, the code might be at fault. And also just, one of the things where design happens in this process is in the refactoring step. Once the tests pass, the things you do after the tests pass to clean up the code, where you notice these two parameters get passed together a lot. This code is duplicated. This class method could be refactored if it wasn't a class method. That's the stuff you notice once the tests pass. And the faster that you can get to the test passing, the more energy that you can have on this part, which is the part that gives you the ability to keep this going over the long term. Okay. I will briefly close off by pushing a couple of things. I work for a company called TableXI. We're a consulting firm in Chicago. We are actually hiring if you are interested in such things. I do a weekly, more or less weekly screencast called XI to I, which you can get at that URL. It sometimes talks about testing. It sometimes talks about project stuff. Sometimes it talks about whatever the hell I thought was a good idea that week. But I like it, and hopefully you will too. Greg, my coworker, Greg Bogus, is doing a site called devpress.com, which is currently just a discourse message board, but will become more elaborate over time, dealing with aspects of clinical depression and other mental illness in the developer community. And if that describes you or anybody you know, really hope that you will check that out. It's an important topic that I don't have time to deal with in the amount that it actually needs. Also on Twitter at TableXI. I'm at noelrappin.com, where you can get this lovely pixelated ebook, Master Space and Time with JavaScript, which talks about some of this topic from a JavaScript perspective. It talks about JavaScript testing and the JavaScript object model. It talks about Ember. It talks about Backbone. You can get it at noelrappin.com. This week, it's 25% off with the coupon code RailsConf25. You can follow me on Twitter at NoelRapp. I thank you for spending like 2 entire conference sessions listening to me talk. I hope that you found that valuable. I'm sorry there wasn't more hands-on stuff. I really encourage you to go in and when you have the Wi-Fi to go in and look at the sample problem and go through this. I will put the slides up at some point today and go through and give that a shot. So thanks for your time and attention, and have a great conference.